Here we're looking at proving trig identities using sines and cosines. And you want to work with the more complicated or the messier side of the equation. So when I look at the left-hand side, that's messier than the right-hand side. And I notice that I've got sine x by itself being multiplied by a binomial here. So you want to distribute sine of x into your parentheses. So that's going to give me sine x times cotangent x plus the sine of x times cosine x tangent x. Now when you look at the right-hand side of the equation, you can see that you're left with just cosine x and sine squared x, which means that on the left-hand side of the equation, we need to simplify this where I'm only in terms of sine x and cosine x. So we're going to first replace cotangent x with its quotient identity, which is the cosine x over sine x. This is going to be multiplied by sine x. And if you think of it as sine x over 1, then you know you're multiplying numerator times the numerator and the denominator times the denominator. I'm going to add to that sine x times cosine x, and we're going to replace tangent x with its quotient identity, which is sine x over cosine x. And again, if we write sine x cosine x over 1, we can look then from top to bottom in canceling. In the first set of fractions, we have sine x times cosine x, and the two sine x's are going to cancel each other out. So we're going to be left with cosine x. In the second set, I have sine x cosine x times sine x over cosine x. So your cosine x's are going to cancel. So you're left with sine x times sine x, which is sine squared x. And you can see that cosine x plus sine squared x has now become what we were looking for it to simplify to, which is cosine x plus sine squared x. So we've proven this using our identities.